Good day everyone! In this video, I'll be discussing about diffraction patterns and polarization.
This video, it will only cover the single slit diffraction and polarization of refraction as being assigned by the group. Stay tuned and let's learn from it.
So first, let us talk about what is diffraction. Diffraction can be described only with a wave model for light, or it refers to the general behavior of waves spreading out as they pass through a slit. From this figure, you can see from the light source, there is a wave of light that comes out. Or you can observe that the apparent bending of waves around small obstacles and the spreading out of waves past small openings. On the other hand, diffraction occurs with all the waves, including sound waves, water waves, electromagnetic waves such as visible light, X-rays, and radio waves. So now, what is diffraction pattern? Diffraction pattern, it occurs when the light from an aperture is allowed to fall on a screen. And it also talks about single slit diffraction. Single slit placed between a distant light source and a screen produces a diffraction pattern. It will have a broad, intense central band called central maximum. The central band will be flanked by a series of narrower, less intense secondary bands called side maxima or secondary maxima. The central band will also be flanked by a series of dark bands called minima. The diffraction pattern consists of a central maximum and a series of secondary maxima and minima. The analysis of single-slit diffraction is illustrated in this figure. Here, we consider light coming from different parts of the same slit. In this figure, we can see that light passing through a single slit is diffracted in all directions and may interfere constructively or destructively depending on the angle. The difference path length for rays from either side of the slits is seen to be the distance between slits and the diffraction angle. According to Huygens' principle, every part of a wavefront in the slit emits wavelets. These are light rays that start out in phase and head in all directions. Each ray is perpendicular to the wavefront of the wavelet.
And this is the formula for solving the diffraction. d sen theta is equal to order number for the maximum times wavelength. D symbol is referred to distance between slits, theta symbol referred to diffraction angle, N symbol is referred to order number for the maximum, and the symbol is referred to wavelength. Here is the example in calculating single slit diffraction. Visible light of wavelength 550 nanometer falls on a single slit and produces its second diffraction minimum at an angle of 45 relative to the incident direction of the light. Now, we have to find the width of the slit and at what angle is the first minimum produced. From the given information, and assuming the screen is far away from the slit, we can use the equation d sen theta is equal to meter times wavelength. So now, first to find is the distance of the slit, and next we have to find the angle for the first minimum. And this is the given values. So the value of the wavelength is 550 nanometer, the value for meter is 2, and the value of second minimum is 45. After, we have to substitute the known values gives. And now, here is the result for the distance, which is 1.56 times 10 raised to the power of 6. After getting the value of the distance, next to solve is finding the first minimum. And again, substitute the known values gives. And here is the result for the first minimum, which is 20.7. From the result, we see that the slit is narrow. It is only a few times greater than the wavelength of light. This is consistent with the fact that light must interact with an object comparable in size to its wavelength in order to exhibit significant wave effects such as this single-slit diffraction pattern.
Next, we have to discuss about polarization by refraction. Polarization can also occur by diffraction, or bending of light as it passes from one medium into another. Most often, the polarization occurs perpendicular to the surface. When a material's refractive index depends on the incident direction and polarization of the light, it is called birefringent. In birefringent materials, an incident ray of light is split by polarization into two rays inside the materials, which take slightly different paths. For example of refraction, I'll be using a transparent material from face shield and flashlight.
When a ray of light strikes the surface of a piece of transparent material, which from a face shield the beam is split. Part of the beam is reflected from the surface, while the rest is transmitted into the material. Experiment has shown that the angle of the reflected light is equal to the angle of the incident light. For the transmitted ray, the path the light takes is bent as it passes from one medium into another.
Brewster's law states that reflected light will be completely polarized at the angle of reflection, known as Brewster's angle, given by a statement known as Brewster's law, where initial n is the medium in which the incident and reflected light travel, and final n is the index of refraction of the medium that forms the interface that reflects the light. Moreover, such crystals are said to be birefringent. Birefringent crystals can be used to produce polarized beams from unpolarized light. In addition, liquid crystals and other polarization effects in materials. While you are undoubtedly aware of liquid crystals displays found in watches, calculators, computer screens, cell phones, flat-screen televisions, and other myriad places, you may not be aware that they are based on polarization. Liquid crystals are so named because their molecules can be aligned even though they are in a liquid. Liquid crystals have the property that they can rotate the polarization of light passing through them by 90 degrees. Furthermore, it is possible to manipulate this characteristic quickly and in small, well-defined regions to create the contrast patterns we see in so many LCD devices. Let's take a look and observe in this sample.
The fundamental purpose of the polarized filter layer on LCDs is to create a clearer and brighter image. Without a polarized layer, the light created back the LCD's backlight, which all LCD won't be visible to user.
And that ends my discussion. Thank you.